In this video, we're going to talk about DC parallel circuits. This is going to be a supplement or an accompaniment to your lab, and you'll be asked to perform a DC competency test for a hands-on practical. As you can see, we do have our trainer board partially set up. First thing that we're going to do, or you're going to be asked to do, is to calculate the resistance of our loads. In this particular example, we're going to be using R3 and R4 as our resistive loads. So again, what you're going to want to do here is take your digital multimeter and we're going to turn it to resistance or ohms. And again, we have the OL symbol on our meter, and we want to do is touch our leads together. Just make sure that our meter is functioning properly, which it is because we do have some resistance. So what we're going to do is take our leads and we're going to measure the resistance of our R3 and R4. If you recall in the series video, we did the light bulbs. In the parallel video, we're going to do the R3 and R4 here. So I'll take my test leads and I'm going to put it across R3 and take my resistance reading, which in this case comes up to 24.6. So I can go ahead and mark that on my paper. Then I'll come over and I'll measure the resistance of R4, which comes up to 49.8 ohms. Okay, so now that I have my resistance measured and written down on a piece of paper, I can go ahead and take my voltage and write that down next. Now, in order to do voltage, we're going to take our multimeter and then we will turn that to volts DC. Okay, so we will go ahead and turn our power supply on, and then what we can do is measure our voltage coming in. So to do that, we have our meter on volts. We'll take our test leads and we're going to test across our power source, and we end up coming up with 12 volts DC. So I can write that down on my piece of paper because you will be doing measurements and calculations for your hands-on practical as well as in the lab. So all right, we've got 12 volts DC, we've got our resistances, so we can calculate our amperage now. So let's go ahead and hook the R3 and R4 up in parallel. So as you can see, I'm running through my power source. One side of my power source comes to my fuse, the other side of the fuse to my switch. The other side of my switch is going to go to R3, and then I'm going to make this in parallel, so I'm going to jump her from R3 over to R4, and I'll do the same on the bottom part of R3 and R4. And then I'll go ahead and connect that back to my power source. Okay, so now we've got everything connected. What we can do is turn our parallel circuit on. So we'll take the light switch, we'll turn that on, and now we can take our multimeter and we can measure our voltage across R3 and R4. So again, you'll take your test leads, and what we're going to do is we're going to come across R3 first, and we come with 8.45 volts, and then we'll come across R4, and we've got 8.44 volts. Now that sounds about right, because in a parallel circuit, if you recall, voltage stays the same. So we've got 8.4 or 45 and then 8.44 volts, so that looks good. So now I'm going to go ahead and turn this power off, and we can now check our amperage for R3, R4, and then for the total circuit. Now in order to do that, we're going to take our multimeter and turn it to amps DC. And remember that we've got to take our red test lead and move that over to the 10 amp slot on the meter. Okay. So now what we do is to test amperage, we want to have this in series with each one of these loads. So in order to measure R1, we will go ahead and hook the meter up like so. And we can turn our switch on and we can test our amperage coming through, which is 0.33 for R1. We'll put this back together here. And now we can do R2, or I'm sorry, R4. We can slide that in there, turn this on, and we can go ahead and complete the circuit. We've got 0.17 amps here. Okay, so all we did was, on our drawing, we just isolated each resistor, R3 and R4, and put the meter in series with each one of the loads. Now, in order to do our total resistance, we can go ahead and remove our wire that's going back to our power source, just like we did in the series. We can connect this in, like so. Turn our power on, and we have 0.5 amps. Now that we have our measured amperage, resistance, and voltage, we can go ahead and calculate our voltage, amperage, and resistance for each one of these resistors, R3 and R4, on a piece of paper and see how close we are. We'll go ahead and turn this off. This is going to conclude the parallel circuit. I know it was a little bit quick, but you should have some familiarity with this now, with the labs that you've been doing, and this will be a part of your performance exam for DC. If you do have any questions, please ask your instructor, and then hope you enjoyed this video, and thank you.